sure there's no audio on that, yeah?
I am, yeah.
an hour and a half of maths is hard enough. Okay? I'm Barry Ryan. Welcome to Julia Martin's little bit of algebra primer or reminder. Okay? So, the interesting thing about the algebra, I know you guys, some of you might have done the logs and exponentials yesterday. I've got a slightly different approach, which is, let's just jump into exam questions. Every exam that's given in maths around the world, be it in Paris, be it in France, the United States, Britain, Hong Kong, Japan, they're all going to follow they follow the same format, it's the same algebra. But what's the difference is the accent of the exam. And that's what a lot of my students say in leaving cert is they get good at their homework assignments, but when it comes down to actually solving leaving cert questions, they go, I'm not sure. Do you know that? Do you ever have that hesitation in maths? You kind of know what they're asking me to do, but I'm not sure what's. If somebody told, I've got a lot of students who say to me, they do the right thing, right? Especially when I got these kind of like classes, just say around Easter or Christmas, large classes of our revision courses at Kilmartin. And I go, there was one young woman last year, and she was drawing some of those trigonometric functions. And I said to her, if I told you it was wrong, would you believe me? And she goes, yes. So I said, so that's what we have to do with this hesitation. So what I want to do in the next hour and a half, I'm going to review paper 1, okay? Because I actually think that's worth 10% as. Okay? And then I'll, of course I don't know who's on the other end of the line. So some of you might have already come to my classes, but my view on this stuff is there's no downside in repeating the obvious. Okay? So, let me just get my pens here. And as I just said, isn't it a wonderful day to do mathematics? I've got a lot of students coming to me. I've got students doing repeating their electrical engineering secondary exam, which they unfortunately didn't pass in the summer on Friday. And I was sending them solutions last night for their exam on Friday. And they said it's been very difficult to do the electrical engineering today, Barry, because the sun is shining. And I said, don't worry, the rest of the week's supposed to be awful. So we can focus then, okay? So, now I'll be constantly turning around to look at the camera, not the camera itself, but to see the feed to make sure that I'm hit. Right? So paper 1, okay? Paper 1 and paper 2. The maths, okay? Right. So paper 1 we're focusing on today, the algebra. So let's just kind of like outline what comes up in paper 1. Some of you may know this already, but I think it's important. So what does paper 1 tell us? Okay. Well, we have section A and we have section B. Section A will be 6 questions, 25 marks each. Okay. And section B will be 3 questions, 50 marks each. Okay. And that's the exact same for paper 2. Okay. Now what's covered in now I'm going to use colour markers, and hopefully that will come across okay with our live streaming. Okay. So here we're going to we'll have, now it's important to try to see, I always think part of my job working for Julie's, or doing tutorials for Julie Martin's, or my principal Julie, is that with some kind of organisation structure, and that seems to work in the past, with some kind of organisation and structure, because I'm a lazy sod. When I was your age, I said, how do I get the marks with the least effort? Okay. So 3 questions out of 6. Okay. So 3 questions. Let me just get rid of the questions so I can have space. And I'll be hopping towards the PDF, so I'll be going back and forth between plugging my iPad in, so we can look at the questions we're going to answer. But I think this is very important. So 3 questions out of 6. This is vitally important, right? And this is one way to truncate your... Now, some of you won't have done calculus yet, and I'm not doing calculus today. Right? This is something that I suggested that Julie and I talked about. Given how difficult this year has been so far for people. And you guys haven't been in school since the beginning of since March 12th, isn't that correct? So 3 questions will be what I call algebra, algebra, calculus, and functions. Now, most of you on this call may not have done calculus yet. But once you do, realize that's the way to consider, in fact, 3 questions. And this calculus stuff and this function stuff, it's very complicated at the beginning, and it is complicated, but the most important thing to realize is that if you regard those 3 subjects as one unit, then you get half of section A. Don't silo them in the sense, don't put algebra into one silo, function, calculus into another, and functions. And the interesting thing, these calculus questions, okay, and I'll be showing you the different kind of function types we need to know for the course. These calculus questions turn out to be, like if you did the one of course I was doing yesterday, you'll notice that those logarithm questions create a lot of rules. By the way, I used to think because I was good at logarithms and exponentials and that kind of stuff that I was good at maths. No. That's like being able to, it's just kind of, it's like moving Lego blocks around, okay? People get scared by these functions, and the only way to learn them, you know, all these kind of weird words, is just doing exam questions. And then you gotta go, what was the big deal? Okay? So that would be half of section A. So regard and all these 2 just boil down to the techniques of algebra that you should know already. So that's one way to make hours of study turn into a shorter time period, in my view. And what about section B? So I'm just sticking with the algebra now. Section B in paper 1, this is just paper 1. You'll get 2 questions on algebra and calculus. Perhaps not functions, okay? Because this is context and applications in section B, isn't it? Okay? So that's very important as well. Okay? So algebra and calculus. So look, so just by considering these 3 topics as the same, you should have, that's good. I always love doing a tally. So it'll be 75 out of 150 from section A, plus 100 from section B. See, that's what I like. That's what as a kid, if I was faced with this project maths, I'd be going, again, In fact, it's not that I've gone to play with my PlayStation or whatever, but hanging out with my friends was very important, right? At that age. So, that's nice, isn't it? And if you regard these 3 subjects, or topics, as the same, as I just said, then you should be in clover. And also, once you realize that, then it makes it quite easy. When I say easy in maths, I don't mean that you get the right answer. What I mean is you just get to the point that you know what, you're able to read questions, you know what they want you to do, okay? What about the other questions here? And this becomes a bit more, I wouldn't say difficult, but just have to be really careful. And this is where students can find it gets problematic. There should be one question on complex numbers. Okay. There might be one question on number systems, a bit like natural numbers, primes, irrationals, that kind of thing. And the link there is your trigonometry. So when you're doing complex numbers, you're doing trigonometry for the hard part of the question. And when you're doing trigonometry, you're revising complex numbers. So again, truncating it, if you regard the complex numbers as a subset of your trigonometry revision, then you should be okay as well. So that's 4, so that's another 25. So now we're at 200 out of 300. Okay. What about the next 2? Well, the next 2 is usually going to be, it's very hard to say. The next 2 should be sequences and series. That's where students don't like things, okay? Good. Now, you could get one sequence and one number system. It's a bit like your junior cert. Right? And then what about section B? That should be a sequence, a series. I'm not trying to in any way downgrade the difficulty of this paper, but I think that's a nice way to approach it. It depends what you want. You know, the marking system is quite weird in the sense that, let's just say, I think this is very valuable, and this is actually part of what I suggested to Julie, was to introduce students to potentially how to approach revision. Is if I've got just say a 25 mark question, okay, okay, it might be marked 10, 15. Right? So the part A will be 10 marks, maybe part B will be 15. Okay? The problem is, if you want to get really high marks, and this is what would have caused me, I think, a headache at your age, the granularity is very low. The 10 mark could be marked, now it depends on the question type, but sometimes it can be marked 0, 3, 7, 10. Right? So 0 marks for no attempt, 3 marks for, say, a standard attempt, 7 marks for a strong attempt, right? And then 10 marks if you get the full question right. Because the exam is very complicated for people to mark it. So my guarantee to you, if you came to my classes, etc., is going from 0 to 3 is easy. But a bit of effort going from 3 to 7 is actually not that bad. The difficulty is going from 7 to 10. Okay? Can't you see that could be an issue, right? So going from 7 to 10 is the issue. So what I found with students is they do better than they expect. But students who want to get a very high mark, to say they're good at maths, see, any error between 7 and 10 is a problem. Okay? Right? Now, there's loads and loads of, there's 9 questions. These questions in section B can have 5, if not 6 parts to them. But if you do something like applied mathsy, each question would be 50 marks. Each question would be 50 marks, and you get, for the 50 mark question, you might have 10 for the opening gambit, another 10, and another 10. So you could get 30 out of 50 just by recognizing what you have to do. Right? So they're very generous on section B. And then the rest of the question, the remaining 20 marks, might be 5, 5, and 5. Right? Okay? So it's going from here to here. So I've had students who are very good at maths, and they didn't need a H1, but I suppose they kind of like wanted to get one. So they kept on finding themselves against this glass ceiling of getting 89, 90%. Right? So high H2. And it's not due to their maths, it's due to this marking system. It's so over the years, what have I had? A lot of students who might want to do engineering at UL. Right? What do you need at UL? Well, blah, 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 just say 450 points, just say. But you have to get a H4 in the maths, so you have to get over 60%. And they get very, very worried about it. But once we started to put this structure together for them, it's not that they relaxed, but they realized, it's not that impossible due to the marking scheme. Okay? Right? Okay? And also, years of exam papers, they got to a point where they went, if you get used to the accent of the exam, it's quite repetitive. What do students find difficult, guys? Right? It is here. Just make sure don't be worried about bad markers. They find these very difficult, and these very difficult. And also they find the complex numbers difficult. But just a word to the wise, so to speak, is people get very hung up on these complex numbers. But they, like the second part of the question, let's say this was a complex numbers question. Just say those complex numbers, they get very hung up on the last 15 marks or the last 10 marks. But remember, that will only be 10 out of 600 when you add up the two papers. Whereas you saw earlier, 175 for the ones in blue, the 3 in section A and the 2 in section B. So I think that's vitally important to know where to put your efforts. I have students who go for medicine. I can instruct the HPAT as well, or help students with the HPAT. And I do say to them at times that, because the points are so high, that the amount of effort to get that H1 in maths is It's not a function of being good or bad at maths, it's a function of the marking scheme. Okay. That if you put an extra hour into chemistry or geography or history or English or languages, you're guaranteed to get every hour you put in, you get rewarded for. Unfortunately, once you get to a certain level in the maths, for every hour you put in, you may or may not get rewarded for. It probably means that you're okay, in the sense it's kind of re-clarifying your ability to get a high score. But if you're looking for that H1, it can be a bit elusive just due to the marking scheme. Okay? One lad 2 years ago, he came out with H2. I thought he should get H1. But he got when they went up to question it, he got 88 or something like that. And they remarked it and they pushed him over the line. But he was very good. He did the mathematical Olympiad, etc. So it's not, it's just kind of like school kind of like kid errors can make it hard to see. You could lose 3 marks just by not expressing the final answer in the way they wanted. Okay, so hopefully that helps a little. I think it really helps. A lot of my students would have said, Barry, just knowing the structure of the exam. And also in here, now, see this algebra, calculus, and functions, okay? Just before I go on to questions. Right, let me see over here, just make sure. Yeah, we can, okay? So this algebra, calculus, functions, there are 3 function types on the course, broadly. There are polynomials. I'll get out of the way of the camera in a moment. Polynomials. Then there are logs, exponentials. Students find those very difficult. Okay? Just manipulating the rules. But as I said, a bit like Lego blocks. So for my students, what I would do is make sure they've done every single question since, I don't know, 1985 or something. And you just get really good at them. Then you think you're good at maths, but actually it's not. You just get good at manipulating the Lego blocks. And the third type is trigonometric. By far, so trigonometric I won't do today, obviously. I'll do polynomials algebra basically. I might do some logs just to show you some exposure to them. But the interesting thing there is the 3 things you have to do, give or take, is you need to, just from your doing research, solve, find roots, factors, and it's a very broad brushstroke, and graph. So here, what the students not realize about the leading cert in my viewpoint, the project maths, which has been around for a while now, okay, is graphing these 2. It's just my experience that when students come to my classes or tutorials, I'm expecting to give them relatively straightforward questions from my point of view, that I thought they would have done in class in depth, and they can't graph these things, okay? And that's a danger, okay? Because I won't say they're remember I said easy. They're easy because you should know what you have to do. It doesn't mean you won't get the right answer. Okay? A hard maths question sometimes comes up in sequence and series. I always use this analogy that if you're playing chess, right? So you've got the first move, right? Or just say you take the first move. You know already what you're going to do. And your opponent take the next move. And then you reach a point, like a fork in the road, don't you? Do I take this decision or that decision? That's when a question becomes hard. So in a maths question, I like to see this a lot in applied maths. If I go down that route, then I'm screwed. The question was designed to go the other route. That's when a question becomes hard. That's why the sequence is serious. Sometimes that's hard because you might find yourself in a situation where it's hard to know which way to go. An easy math question is there's no choice. Underlying all this, okay? Underlying all this, and be careful of this, probably what I'll start with is Pythagoras. Both in paper 1 and paper 2. Pythagoras is, at times, that could be out of the 600 points, Pythagoras could be 150 points. Basic, your junior cert geometry, 70% of paper 2, of outside of probability statistics. Okay? So those two things and constructions. In fact, I think to get on well with this, and you have to draw them, and it takes some effort to get this. It takes a lot of effort actually to get used to, especially those radiant class. I know you guys left school on March 12th, and some of you have teachers who were continuing with the course in detail and leave class here. Okay? So just give me a second and see if I'm able to plug in my own computer into the system. A lot of my students prefer, yeah, well, I can't mute this, right, because it's just a different system we're using to live stream, given the fact that anybody can log in. So I can't mute it, but usually my students like me muting it so they don't have to listen, because I've lived outside of Ireland for many, many years, but I talk too much. I'm an Irish guy. Right, okay, so let me see if I can plug this in. And let's see if we can start doing questions. But I think that's very useful on the board, guys. We may not look at it. But some of my students who got, one student needed to go to, he was very bad. He wanted to do pure maths at Cambridge in the UK. He said to me so he did H1s in mathematics, physics, applied maths at least. Then he got his interview. He was just brilliant at maths, so there was no point of problem with it. He was just getting into the interview, and he said, just having that outline for paper 1, and this is a similar outline for paper 2. He said to me, he was very bright, he said, I just think that adds about 10%. He said, I think that added 10% to my mark, without actually studying any further maths. See if this works. It should, but it may not. Right, if it doesn't, we'll go back to the board. Okay. Let me just see if it works first of all before I go. It does. So let me just go back to here. And I can zoom in and out. This should be on our system, and you guys have access to it, but just in case we don't. Now I'm going to start with some relatively easy questions. But again, remember my usage of easy. It's a very big file I sent, so you may not be able to download it. Okay. Wow. So you might have seen, let me just see, they're not rendering corrected. That's not right. Came up a moment ago. Very good. You thought a moment ago. Okay. So let's start with just going back to the whiteboard. Get rid of all this. Surprisingly, it works from one moment to not the next. So it's better on the end of them. doing algebra. Okay. Some of you haven't done calculus. So I'm going to start with, that Pythagoras is so important, okay? Start with one of those. Let's try that once more, guys. Ah, no, this is a length problem. No, it's not. Doesn't like it. Okay. So we have, now I've got rid of that from the board. What techniques do we have to know for the algebra? So some people get very comfortable with certain types of it. So over here, we need to be able to do simultaneous equations, as you guys will have covered in depth. And closely linked with that is these inequalities. Then we need to be able to do quadratics, cubics, and you need to be able to do, very important here, you need to be able to graph them. And then you need some tricks of algebra, that's what I call them, tricks of algebra. I don't know how many people are on the call, so I don't want to make it too complicated. This is supposed to be just a primer or reintroduction. And the tricks of algebra with things like surds, binomial theorem, that nobody likes, but it's actually not as bad as people make it out to be. The surds, binomial theorem I would have been okay with it as a case. Surds, it would have found a bit difficult. And under algebra, I always put exponentials and logarithms. And again, I have to be able to draw all these. So this is the ones, after a while, that's the ones graph them. Okay. Right. And also then we have this modulus function, which I wouldn't have liked as a kid either. But it's very important because it's used extensively in paper 2. The modulus allows us, see, in maths or in sciences or physics, we can get a length of something, and the length might come out to be negative. And no lengths can be negative, at least at our kind of pay grade. so we use this modulus function. And that can get a bit confusing, okay? But there's some nice tricks with that. And then you've got these rational functions. And you know, guys, that's basically all algebra for that course. So these quadratics, the only difference is, compared to the juniors, well, we get into the juniors as well. These quadratics, you need to know vertex form. And you need to know, the conditions on roots. Okay. Let me just do something just to start with, just to remind you. Okay. If I ask you to factorize, and I'll give you a couple of minutes, factorize, me too. See the way about truncating the course, guys? Wouldn't that be like so? And I used to say to students, and some students actually took the advice, and I said, like, when I was in 6th year, or you were good in 6th year, I'd go, okay, Barry, Sunday afternoon, because you haven't done algebra in ages, or kind of, these kind of tricks of algebra, etc. in ages. So I'm going to spend 3 hours doing algebra this Sunday. Not that snowball's chance in hell would not happen, right? Because what would happen would be, I'd have an English composition, or a French essay, something like that, which I put on a long finger, right? Because I was playing football with my friends or something like that, or out playing squash or hanging out. so the 3 hours to do the algebra would be eaten up by the fact that the English composition was due on Monday. Right? So I said, there has to be a way around this. So what I started to do was every week, independent of my maths homework, was I do, one day on a Monday, I do 10 or 15 minutes of the simultaneous equations. Then 3 days later I do quadratics. 3 days later I do cubics. Only 15 minutes each, right? In other words, I got used to the fact how lazy I am, right? How much of an idler I am, right? And that was true when I was doing my PhD as well. I was going in theoretical physics. I was going, I'm meeting my advisor on Friday. I had to meet him every Friday. So what happened was, what did Barry do? He stayed up until 6 a.m. Until Friday morning just to get something done so you could get through the... I love the physics and all the rest of it, but I'm just saying, so some people are very organized. And what I find that just if I organize myself, I reduce the time. Right, so could you factorize, and you don't have to obviously respond to me because factorize x squared minus 5x plus 4. Okay, just to start with. Very junior cert. First of all, and let's put it over here. What are the techniques from junior cert that your teachers might assume you know off by, you know perfectly? Techniques from JCH in algebra. Well, it's multiply, add, and simplify. Right, yeah. Factorize. Solve. Graph. And a junior cert on polynomials, where polynomials are anything with an x squared into an x cubed, an x to the power 4, an x to the power 5. Graph. And find the roots and the factors. Right? So again, this is kind of like a primer, just to kind of reintroduce you guys to your maths. Factorize means put in brackets. And also you need to know the minus b formula, don't you? So, now here, there's a difference between, I know this sounds kind of trivial, but it's actually not. I find this stuff kind of students, they do it in 5th year, but the 5th year sometimes the teachers kind of start asking DB pre's rather than making sure some teachers realize that students aren't going to be fluent in the junior cert. So when I say factorize this, I mean to put it in brackets. So that's going to be, just by eyeballing it, mustn't that look something like putting in brackets? See, there's no equal to 0 there, is there? Right? That's very important. So this is an algebraic expression. Okay? And what I'm going to do is factorize it, find the roots, and quickly draw it. Okay? So that's going to be x, and another bracket x, isn't it? Because x by x must be x squared. And then there's going to be 2 holes, so to speak, left here. And for quadratics, they must be 2 numbers. Right? Sometimes it doesn't work out where you can't factorize it by eyeballing it. And whatever's in those 2 slots must add up to plus 4. Right? So I sit here and go 4 has factors 4 by 1, 2 by 2. But also minus 4 by minus 1, and minus 2 by minus 2. Sounds trivial. Now, because there's only an x squared here, when I add these 2 factors here, 4 here, when I add them together, I must get minus 5. So it must be minus 4 by minus 1. Right? So now they're called the factors of the polynomial from over there. Sounds easy. Right? Then, if I'm asked to graph it, very briefly, I'm asked to graph that. Well, that's going to be my xy plane. I know what the roots are. The roots are the values of y where that equals 0. Now, what are the roots? The values of x that I put into here get the red 0. That must be plus 1 and plus 4. Okay? I know this sounds trivial, but it's actually important. Where does it cross the y-axis? It's when x equals 0. So it's when y equals plus 4. That will be another one. I'm trying to show you a harder question later on. Now, this is of the form, this will be kind of going back to our quadratic, ax squared plus bx plus c. Now, these a, b, and c, they're called the coefficients. Again, there's a bit of lingo or mumbo-jumbo in this stuff, okay? Right. So we have two types of quadratics. They're also called parabola. You'll find that we also call these parabola. Or parabolae. Very. I think one of my professors at UCE, when I was a kid, used to go, parabolae. And I go, is it A or parabolae? If a is greater than 0, so we just get rid of the factorize. So the most important thing to say, when they say factorize, it's put in brackets. But it's not necessarily the minus b formula. Okay? So when I factorize, I get the factors, and I also get the roots for free. So if a is greater than 0, it's U-shaped. If a is less than 0, it's M-shaped. And it's the latter, it's this guy here, which is very important in section B of paper 1. Because when I lob a ball into the air like this, there's no air resistance. It follows a motion like that, which is an N-shaped quadratic. Right? Okay. Little things like that in the context and application. Context and applications can be quite easy, actually. So this must be U-shaped, because A is 1 here, isn't it? And I know it must cross the y-axis at 0, c. So without actually doing any work, I've already got a lot of information. So that must be 0, 4. And from our factorization, that must be 1 and 4. And it must be U-shaped, so I can quickly. I know this sounds trivial, therefore I get this. And it must be symmetric. And that's where your vertex form, and then your calculus comes in. It must be symmetric. So between 1 and 4. So that's going to be 2.5, isn't it? So the very important symmetries, again, in the paper that people forget. That's symmetries from your junior cert. I know it sounds. The difficulty with maths, I always found, is it starts easy. And that must be. There must be a minimum value of y, that no matter what value of x in, I never get a y value. I never spit back a value less than that. And that red dashed line there must be the, so if I put my hand like this, the blue curve on the left and the blue curve on the right are mirror images of each other. Okay? Right. But here's where it gets complicated. Aren't there an infinite number of, so I've got the roots, haven't I, here, which are given by the factors. Remember when you did the equation of the line, and you might have done it already in this here, when we did the equation of the line, don't you get to a situation where I can tell you that the slope of the line is 2, just say, so it's going from lower left to upper right, but that doesn't pin it down. There's an infinite number of lines with slope 2. There are an infinite number of quadratics with factors 1 and 4. So see, at the draw, is there going to be another, infinite number of them, but there's only one with the green one, right? Do you see what I mean? So the green one is just like if you tell me the point in the line of the slope, then I nailed it down to an individual, unique line. But if I don't know what this point is here, couldn't I have another quadratic coming in more shallow with just the exact same roots? It's the most vital thing, okay? And then I could have another quadratic coming in like this guy. And so on and so forth. That's a very important, my phone's going, just 1 second, guys. That's a very important consideration, that. Okay? Very important consideration, because I remember there was a group of students came to my class, and one girl turned to the other at the back and said, now I get it. Okay? So, what you find is infinite number of them. So how do we then go from our junior search to slightly more sophisticated? What we do is as follows. It's very, very clever. And solves the whole course. Makes this whole thing, especially when they give you graphical information. If I tell you the roots, just say I tell you, now I'm going to get a bit more mathematical. If I tell you the roots of a quadratic are x minus, let's call it x1, just to be really creative, okay? And x minus x2. Right. So they're the factors should I say. Right. Well, we know the roots must be, this is a very, and this will apply to an x equals x2. Then, we know that the quadratic, in this case, must be a times x minus x1. Try and realize this could be, remember I was going to describe you the algebra, calculus, functions. This piece of information is what could make the course. In other words, make your life easier. Right? And then all I need, but there's an infinite number of those a's. Just like, so what I told you, when I give you x1 and x2, or x minus x1 and x minus x2, all I'm telling you is, there's an infinite number of polynomial or quadratics going through those two roots, x1 and x2. But I haven't pinned it down, just like I told you the slope of a line. So I need one more piece of information. Just one more piece of information. Right? And with one more piece of information, then I can nail down the A. Okay? Right? So that's kind of, if you follow that strategy, that will apply to quadratics and cubics as well. Okay? Right? So, unfortunately, I've tried earlier, but I can't seem to bring it up briefly, but it doesn't seem to last on the system. So, let's see. Let me just give you a question, and again, you can't respond to me, obviously. Okay. I'm going to tell you, let's see. So I have to draw these on the board. So, yeah, so this is from 2014, and this is the kind of stuff I really liked. So, I just can't, I only remember things from being a kid where if I found something difficult, then I'd remember it. I'd remember as an old man, only 3 olds, not 4, right? If I remembered something, then I'd go, that was a difficulty. I don't remember being told this. I remember working it out, but I don't remember being told it. So, here's an exam question. And now, I just think that's actually probably what, in my notes, you'll see that if you've got access to them, they're uploaded. you'll see that kind of information. So let's now see that in action. It came up in, some of my students wrote to me instead of Hushbarry. It came up in, some of my students wrote to me instead of Hushbarry. It was 15 marks. Well, actually, when I counted them up, the DEB previous year, that little piece of trick there, that just tiny piece of maths, I think solved about 50 marks out of 300 in paper 1. Just knowing that. So, but sometimes it's difficult to know how they're asking it. Okay. So for 2014, they just asked this. I'll give you a few minutes to actually try it yourself. So for 2014, paper 1, they asked a function. So for 2014, we go a function, and again, don't be put off by this, right? F of x satisfies f of minus 3 equals 0, f of minus 1 equals 0, and f of 2 equals 0. It cuts the y-axis. At 0 minus 6. Okay? Verify. See, the students just say to me, Barry, once you do it on the board, it's fine. Verify f of x can be written in the form x cubed plus 2x squared minus 5x minus 6. So, see, that's not difficult. It's quite easy, but I have to be able to read the English, okay? So I can't bring up my notes on screen. That's the question. So I'll give you a few moments to think about that. It's again the way they write it. There's a lot of progress this morning because it reminds you of everything you need to know. And I'm going to erase this on the left here now in order to make room. So I'm going to use this to springboard into other concepts. But the first question you have to ask yourself is, what's minus 3 minus 1 and 2? What do we call those? They're the roots, aren't they? Right? They're the roots. Okay. That's the first kind of like, not complicated, but because you've so much else going on, you've got, what's your play? Is the Merchant of Venice or something like that? Or, no, it's King Lear, isn't it? King Lear this year, isn't it, in 2021? So you're trying to memorize that. And then you've got more technical words in sciences, just say, or geography, or economics and business. You see what I'm having? I've jumped straight to the quadratics and cubics because I think the students get good at the simultaneous equations. But I think sometimes though it's very easy just to get to the point where you follow the recipe, but you don't think about what you're doing. Part of my job is kind of make us know what we're doing, okay? So, looking at this here, so I can answer straight away. So the first thing I go, is it linear? Quadratic? Cubic? See, a linear equation, like y equals 3x plus 5, only has only one root. A quadratic can have most 2 roots, okay? And 1 hump. And a cubic can have most 3 roots. So here we're told, and what are roots? So let's be mathematical about it. So I'm going to say y equals f of x. That's your function kind of format, okay? And if I tell you, if f of minus 3 equals 0, that's your value. That's another kind of thing over here from your junior cert. Value. What I'm saying is I'm putting x equals minus 3, and I'm getting 0 back as y. So, and then I'm told f of minus 1 equals 0, and f of 2 equals 0. That means minus 3, minus 1, and 2 are roots. That's the first piece of information. And there are 3 roots, okay, which means the cubic. Right? Okay? Aha. Means the cubic. And then I can say, so it's cubic, they're the roots. And then I can say, what are the factors? Well, the factors must be x plus 3, x plus 1, and x minus 2. Remember, this is a 10-mark question in algebra from paper 1. Now, here's what I'd say is, okay, how would I approach all of these? There's an infinite number of cubics going through those 3 points, just like there was an infinite number of quadratics going through the root 1 and 4 for the quadratic earlier in the previous question. So what I do is put that a in front of it. Right? And once I determine a, then we're okay. Right? Again, I can't ask you if that's making sense because this is a field remote. And how do I find a? How do I find a? Well, I'm told it goes through 0, 6. So it says when x equals 0, y equals minus 6. Be very, now, all you have to do is multiply these out, and you'll get this out here, okay? But I want to make sure we're right. I want to find the value of a, because, again, the thing about truncating the course length is to find techniques you can recycle or apply it over and over again. Let's put that in fancy terms. So y equals fx, so therefore minus 6 equals f of 0. And I'm saying f of x must be a member of this family. That might seem mathsy, but you'll see it bears loads of truth. Okay? So when f of 0, when I substitute x equals 0, I get back y equals minus 6. So f of 0 will equal a times 0 plus 3. So I know this is easy. Well, I don't know if it's easy for some of you, and that's just going to be a times minus 6, isn't it? And we want that to be minus 6, so a equals 1. And you'll see that time and time again. In fact, actually, after I do this question, I might go on and do the DED3 question that came up in 2019. We have to get, you remember I was talking about function types, we need to get used to these, and then the question can morph or change into a question, or mutate into a question on calculus, or the range, so it can become functions. Okay. Right, so, see that was a bit la-di-da, right? And all I have to do is multiply this all out. Now a is 1, so we remove that. Okay. See, it's just a recipe box, okay? A couple of years ago, there were 2 kids in the back of my Easter course. They were very good at maths, and one trying to do the other, and that was just what was missing. Now, just as an exercise, that's x plus 3, and then I'm going to multiply this out, so I get x squared minus 2x plus x minus 2, which equals x plus 3 times x squared minus x minus 2, which also shows, just so you know, that also means x squared minus x minus 2 is also a factor. Again, something as a kid I think I would have gone, oh, okay. But remember I said earlier, when we first started, I said, that might be something that I would have known, but it would have been strange. Okay? That means that must be a factor. And then if I carefully multiply that out, I get x times x cubed, x squared, so I get x cubed, x times minus x, so minus x squared, x times minus 2, so it's minus 2x, plus 3 times x squared, minus 3x, minus 6. And then gathering like terms, and we just kind of multiply out and simplify. It's not what I've just done there, multiply out and simplify. We have a junior cert technique. X squared plus 2x squared minus 5x minus 6, which is indeed what they asked us in the question. Okay? I think that's a nice thing to be able to go into 5th year feeling, and 6th year, let's say, feeling a bit more comfortable with. Just reminding yourself of, okay? Because it's marks are marks, don't care where they come from, right? Okay? So, now, let me just go to the yeah. Honestly, guys, I think that's very valuable. There's loads of little tricks that have to be learned as well. I think that's very useful. Because I can't bring this up on the screen. I don't think I can. If I can, just once more. It's good for you guys to see the way it's written. I'll try it once more. I have to have a chat with people in the office as to why this is not working. Yes. Okay. So, hopefully everybody can see that. Let me put it into, yeah, okay. So here's from the DED pre. So this will be DED pre, you can see 2020, okay? 2 hours, 30 minutes, 300 marks, okay? Right. So this will be part B of question 1. So I'm going to give you a few minutes looking at that. I can put you on mute, so I'll try not to talk for a few minutes. See, that's exactly the skill we've just done there, okay? Slightly more sophisticated, but if you follow the same routine, do you see what I was trying to say earlier? If you think about it, guys, what we're really doing here is the exact same scheme I just put on the board for quadratics, and then that 2014 question. So what do we notice here? And I can use my pencil, I hope. Well, no, let me not do that, just in case it's not like it could be my PDF formatted in my. Okay, now. Remember, we can have double roots as well, can't we? Mind you, everything on that graph is all I need for my A, B, C, D. And the reason why I'm doing this morning with you guys is because it is the exact thing that people, let me say if I complicate is the wrong word to use, but where it goes a bit wrong. So, let me go back to the board. Clean the board again. What have I tried to achieve this morning so far? It's got a review of the algebra, kind of type, the topics in algebra you need. Remember that this question here, we could suddenly morph into a question, and I'll show you in a moment, which requires calculus. And it is a function. It is a function, guys. And I'll draw this quite large on the board. And try not to forget your good old junior cert algebra. There's so many marks, and students don't realize it's so many marks rewarded for knowing your junior cert very well. See, I hate getting classes unless we touch base with the exam itself, because otherwise there's no point. A lot of students say to me, I think the textbooks are very good, by the way. A lot of students say to me, Barry, I can do the questions in the textbook that the teacher might give me somewhere. But the minute I see an exam question, they just seem to be asked differently. And I think that's a thing to do with confidence. Right, so what do we have here? And also, a very valuable lesson here is, remember, when I was a kid, maths paper 1 would have been 3 pages, and maths paper 2 would have been 3 pages. But relatively dense kind of maths questions. Project Maths can be up to 18 pages per paper. And so the idea is they want you to have a graphical understanding of things. Okay? And they want you to draw things, and they give you the diagrams to draw them. But the most important thing to realize here is, and students get not confused, but they just don't seem to realize, is the scale of the x-axis and the scale of the y-axis can be different. Here's the scale of the x-axis, and they don't have any boxes, you notice. So it goes across 1, 2, and 3. And then it goes, let's say, -1, -2, -3. And then look at the y-axis, though. Okay, just going back briefly here. Look at the y-axis. The y-axis is going to go up along the same units, and do be very careful with that, especially if they give you the grid. You know that grid has centimeters. Then we go up 8, 16, 24, and 32. And I think they get to 40, something like that. So remember on the board, and then -8, -16. And then the graph seems to come in something like this. Comes in like this. It glances off the x-axis, goes through 24. Better. Goes through 24 and comes out at +3. One way to say this, and that's +3. And the little technique I used for that 2014 algebra question previously is, what kind of function is it, first of all? It's a polynomial. It's got 2 humps. Okay. 1 hump here and 1 hump there. Which means it's a cubic. And it has 3 roots. But here, the roots, so it's a cubic, okay? And the roots are where I cross or touch the x-axis. So x equals -2. But that's a double root. I like this question. Okay? So they're the roots. So it's got a double root here. And it crosses at 24, doesn't it? So let's call it y equals, so f of x equals ax cubed, as they tell us, plus bx squared, plus cx plus d. Yeah? Okay. Those of you who are in the know now realize that d must be 24. So f of 0 must equal plus 24. Because that's where I cross the y-axis. So I've got d, because f of 0 will equal a times 0 cubed, plus b times 0 squared, plus c times 0 plus d. So f of 0 must equal d. So we got one of them, haven't we? So we know d is 24. Right, remember they asked us to find a, b, c, and d, didn't they? Okay? Right? Now, what about next? Now, so that's kind of like, at least we've got some marks in the table, don't we? Then you'd say, so if -2, and 3 are roots, then x plus 2 by x plus 2 by x minus 3 must be the factors. And then I stick an a in front of it. Right. Now I need to determine a. Just like I did with the last question. It works a treat every time, okay? So f of 0 equals 24. When students see this and they get used to it, that means a times 2 by 2 by minus 3 must equal 24. Okay? So that's going to be a times minus 12 equals 24. So a equals minus 2. Now again, I can't ask you guys whether or not that makes sense. But you see, this is kind of slightly more grown-up version of what so I started with x squared minus 5x plus 4. And probably some of you at home are going, what's doing that for? Then I did a 2014 question where a was 1. They just asked me to multiply out the factors. Here's a DEB pre. We're using the same trick, but now it's slightly more complicated because a is minus 2. But I followed the same recipe, didn't I? And once you get comfortable with that, it's an enormous relief. Because it's almost like you could put a line through one of the techniques, especially graphically. And I know inexperienced students find this difficult. Because they think, you know, it's not laziness or anything. They think they just take the factors here and multiply them all out, and they should get the right answer. It doesn't, it's not quite as free a lunch as that, okay? So now, if you see the way I just followed the same recipe, if you can get good at graphing these things, you will get, I won't call them easy, they're trivial, but there's a lot of low-hanging fruit. And this is a DEB question. Now, how am I going to find A, B, C, and D? Well, there are many ways to solve this, but I think it's just, you know, following that straightforward example makes sense. So now I'm going to say, so I now know A and D, so f of x equals A times x plus 2 by x plus 2 by x minus 3. Don't forget, when minus 2 is a root, x plus 2 is a factor. Because when I put x equals plus 2 in here, or minus 2 should I say, I get back 0. Okay. So that equals minus 2 times x plus 2. I get very excited by this because I just know the students like it. So let me just do this, I'm going to do this quickly. So x squared plus 4x plus 4 times x minus 3. That might be better to do it like this. Just so it... the maths is the same, it's just so you don't produce an error. So that will equal minus 2 times x cubed plus 4x squared plus 4x minus 3x squared minus 12x minus 12. To equal minus 2 times x cubed plus x squared minus 8x minus 12, which equals minus 2x cubed minus 2x squared plus 16x minus 24. So the way you finish answering the question, guys, would be, you'd say, try to put my hands in my pockets so we don't move around too much. I like moving around. It's kind of like... But apparently I'm not supposed to. They've got a line here, in tape on the floor, and they go, Barry, don't move outside the line. I go like this. What are you hoping to do? To go like this? Okay, so I write down, my answer would be A equals minus 2, B equals minus 2, C equals 16, and D equals minus 24. What happens with students, that goes from being a question to being and all I have to do was this. See up here? That's all I needed to do to get so it goes from, and then this can morph into a calculus question, okay? And the calculus will tell me things like, calculus will tell me the coordinates of that and the coordinates of this, what we call the minimum and the maximum. So remember earlier I said 3 questions in algebra. Now I think in this question they didn't morph into one of those. Remain like that. Remember, these DEB periods can be quite difficult. Okay. Yeah. Now, here's a trick question. Some of you might have already come to my classes during the summer, but I think this is... Now I'm going to do a simultaneous equation, again from the DEB pre 2019, paper 1. See, now each year there's a different emphasis. One year could be more calculus-based, and some years can be very sequences-based. My experience is kids don't like the sequences-based. So after we master the algebra, what I tend to do is spend a lot of time with the students coming to my courses on sequences. Because remember I mentioned earlier, if you want to go to UL to do engineering, you need a H4 at least, okay, in maths. So you get the points, you only get a H5 in the, so you've got the points to do the engineering on paper, just say you got a H5 rather than a H4 in maths. They allow you, they're very kind, they do a resit in August, right? Which is just 1 3-hour paper. So last year, there was nobody. So we advertised it, you know, 2-day course, 3 hours a day, and then you do the research on Friday, let's say. But last year, nobody came in 2019 because paper 1 was very algebra and calculus based. The year before, the room was full of students because it was very sequences based, right? Quadratic sequences, geometric sequences. So the students all got H5s, simply because they couldn't remember the equation for a quadratic sequence, because it's not in the booklet, in the formulas tables. A bit of a bummer. But so obviously, when it's sequence and series, students, if the theme is more sequence and series, like there were 3 sequences questions in section A and 1 big 60-mark question in section B on sequences, and they're quite difficult, right? But so I'll need to determine, you know, for students who don't get the scores they want in the predicted grade system this year, you know, the Leaving Cert's not cancelled, it's just postponed. So if you're unhappy with your grade, but the government has said, you're very free to sit the exam again, or to sit the exam as you would have. I think that's a bit of a cop-out in the government's point of view because you miss the placements for university, but that's their way of, I think, getting around the appeals process, in my personal view. But then again, what else can they do in the circumstances that our civilization is going through? So I'll have to see the exam, because that will give me an inkling as to what the 2021 theme might be. Okay. I thought that was a nice question. And when you broke it down like that, so you go, what kind of function is it? Remember, all you're looking at really, is it a line, is it a quadratic, is it a cubic, is it a log or an exponential, or is it a trig? And if it's not any of those, then it's probably a polynomial higher order. Like you might get a thing called a quartic that you would have done in 5th year, but you might have gone, you know, it never comes up, so you kind of swerve it. But you can't do those without an understanding to do quadratics and, or good old quadratics and cubics. But if you follow the same line of reasoning, it's the exact same question. And here's an interesting one. Would you do this like, you know, would you do this exam at some point in the not too distant future? So, well, look at this question here. So this is from the same paper, guys. I want to solve the simultaneous equations. So I've got 2 simultaneous equations. 4 over x plus 3 over y is minus 5. 2 over y minus 3 over x equals minus 19 over 4. How would you approach that? If I had, at your age, see, simultaneous equations I have no problem with. Okay? Now, my students who come to me regularly, this question would have been asked, this type of question on simultaneous equations would have been asked in the 80s, 90s. So I make sure my students are covered on different ways they've asked the question. So here you've got the DB pre, and what they're doing is dipping back into previous Leaving Cert questions from the 80s and 90s. The same with physics. Okay? Since you know you get your study clicks, and most students just limit themselves to what's available on study clicks, or available in the exam booklets, you know, that you buy for matinees or Easterns. Okay? But no, see, it makes sense. If I was designing questions to be asked on the Leaving Cert, just I was asked to submit questions as an example, I don't want to. I wouldn't want, if I make the questions too difficult or too obscure, they wouldn't ask me again, would they? So what's the safest thing to do is go back to questions that were asked already on the Leaving Cert but maybe from the 80s and 90s, and as long as they were still in the curriculum, to reformat them and submit that as a potential question. Okay. So this says, I'll just write it on the board while we're looking at it. I think this is a great question. It's from the same paper. So what did we have? We had a cubic, we had roots, factors, and that little trick that we have. Through those -2, -2, and +3 roots, we could have an infinite number of cubics going through those 3 points. And to kind of nail it down to a specific unique one, we needed that 0, 24, didn't we? Or some other point on the cubic as well. It could have been another point they could have given us. Yeah. So let me just write this down while you're looking at it. So I think when I was your age, I think I would have worked it out quite quickly, but I would have gone, that doesn't look like my regular. That doesn't look like the regular simultaneous equations. But it's a good trick, and we'll be able to use it. Again, it should be able to be recycled. The algebra may not be nice. So, how would I solve that? Okay. Well, I could cross multiply by xy, couldn't I? It would work. Or I could do something clever, which you probably saw maybe yesterday when you were doing, if you joined Niall's logs and exponentials. Look at this trick. How if I say a equals, just try this, a equals 1 over x, and b equals 1 over y. It's kind of a substitution trick, and that's what we use all through the course. Okay? Well, doesn't that rewrite that as 4a plus 3b equals -5, and 2b minus 3a equals -19 over 4. Ah, now that becomes more familiar, doesn't it, guys? That becomes more familiar. And then when I solve for a and b simultaneously, then I can't forget to do this here. Okay? Right. So, now, what's the easiest thing to get rid of? It's probably the a's, isn't it? And don't forget, it was like that, wasn't it? And then I go back, or you'd be clever, but then I go back and go, just make sure, yep, so they have them the opposite around. So if I multiply the boss, so to keep track again, multiply this one by 3, and multiply that one by 4. Okay. Let's rewrite them over here on the right so I don't obscure the board. So it would be 12a. It's a neat trick, isn't it? But I think if you hadn't seen something, like all my students who did the DB pre this year, would have seen this question from the 1980s and 1990s. And it's not that, you know, the student would have found it easy at the time. It's anything that prompts your memory that allows you to tackle the question. So there'd be 10 marks for this out of 25. So you'd have maybe, can't remember the marking scheme for this specific question, but you'd have 0, 3, 7, 10. And see, by doing what I just did here, and getting to this point, you're going to get 7. So even if you screw up the numbers, you've got high attempt marks. And I'm notorious at screwing up these numbers. I'm very bad at arithmetic. So that's 8b minus 12a equals -19. So it's kind of designed, that -19 over 4, can you see it was almost designed to get rid of the 4? So I add those two together, don't screw up, Barry, and I get 17b equals, now, that's -34, isn't it? So b equals -2. Aha, right? And let's go back and calculate a, and it's probably best to go to this one here. That means 4a minus 6 equals -5. So 4a equals 1. So a equals a quarter. 10 marks, right? Right. So, yeah, students get good at simultaneous equations, except for screwing them up. You know, that can happen. You know, as I said, I don't know the students on the course, because like 2 or 3 years ago, I was doing one of these simultaneous equations, you know, x, y, and z. I was on the board, and then it didn't work out. And this young student, she said to me, Barry, when you started, you multiplied by -3, but you multiplied by 3 with one of the components. And I said, oh, okay. And I went like this, why didn't you tell me? Okay, right, so I'd be very careful with these. But this one's a nice one, see? So therefore, so x equals 1 over a, which equals 4, and y equals 1 over b, which equals minus a half. That's your answer. But I think that's hard, unless, it depends, it's not difficult, is it? It's just be, now you could have cross multiplied by x and y, and got that to be 4y plus 3x equals minus 5xy, and this to be 2x minus 3y equals minus 19 over 4xy. Then changed the things and got rid of the xy, and then you would have ended up with two simultaneous equations in x and y again. That would have worked, but you see that's the way the question was designed to be answered, wasn't it? Right. Again, if you're coming to my regular class, I could sit there and ask you what you thought of that, or if you guys were physically in the room, I could ask. I think that's a nice trick. It's a little trick. Remember I said tricks of algebra earlier? That's the kind of thing, if you start getting comfortable with the algebra, calculus, and functions, then when you go back to revise, instead of doing the same thing over and over again, you go to my little pack. I've got a little pack of unusual questions. Not every question from 1980, but kind of unusual ones, where I would have gone, I had a friend in London, he's a Dubliner, but he used to meet him in, instead of my apartment in Notting Hill, but we'd meet and he'd go, if something happened in the financial markets, he'd go like this, tall bloke, very funny, he'd go, oh no, I haven't seen that kind of thing before. So I go back and go over the exam papers when students get more prepared, and I go, look at the question, I go, okay, the kids are okay with that, I think. The kids are okay with that, the students are okay with this, and I go, oh hello, I wonder if I've been honest with myself, but I've been okay with that at your age, okay? So that's an example of it. And, at Kilmartin, we've done quite well at, I wouldn't say predicting the papers, that would be, it could be just luck. But, on the Leaving Cert has become, project maths has become a little bit more mathematical. It's become a little bit more like pre-project maths. If 2019 was anything, the actual Leaving Cert in 2019 was anything to go by. Okay. So got a little bit lucky in 2019, 2018, 2017, in the students had seen the questions before from the 1980s and 1990s and maybe early 2000s. Okay. So, now look, is there anything else in this paper that we can do in algebra? That's unusual for you. Yeah, here's something I want to do, which is algebra and geometry. Don't be scared by this. See, I give a course on Fridays, and students have come to it for quite a while now, over the summer. And almost exclusively, except for exponentials and logs, almost exclusively, I've tried to get them used to section B questions, the big 50-mark questions. And this is a very good example. So I'll finish off with this question. I think it's very good. So when I said algebra, I think, okay, so we have our cubics, our quadratics. Okay. And we don't need anything beyond junior cert maths to do this. And this is from the same DED3, paper 1. So I realize you guys haven't been in school since March 12th, and that's why we said we'd just give you, if we're going back to school, just a bit of just a tiny bit of kind of reintroduction. So this is a very popular type of question. Cones inside spheres, cylinders inside cones, and these turn out to be calculus questions. The beginning part's okay, but you have to have seen something like this before. So let me draw this while you're reading it. Okay? And I think that's very helpful, isn't it? Okay, so that's a sphere. Circle. And inside I've got a cone, a right-angled cone. And see is completely confined by the sphere. ABC. I'll put on the screen again. B and C. And then we've got the center of the sphere. And the sphere has a radius of 12. Equals 12. Now, students, what happens is, my experience with guys is that students come to me and they start getting very good at section A, context and application. Just say they came to me in 5th year. Then what happens in their summer exams is they do very well in section A, and they just haven't had enough exposure to section B. So this is just a bit of geometry, but it's really an algebra question. So I'm asked to find the length BC, which is, that's the radius of the cone, isn't it? Okay, guys? Radius of the cone is BC. And we're going to allow OC, now I'll put on the screen again. Back to me. So now I'm going to allow, I have to read these questions carefully. So now think about this. It's very popular in you know, it's actually this year on the PED pre. Some of the kids actually came to my 5th year class in Limerick. What happened was I would do a lot of these cone questions because the kids don't like cones. The last time they really did them in Anchor would have been the junior cert. And I said, you guys are going to call me the cone guy, right? Yeah, you're the cone guy, okay? So now they give us a bit of a hint here. They tell us to allow. Let's do a hint. They tell us to say this length here, length OC equals x. And they ask me to find length BC, find length BC in terms of x. Okay. Now, just before we could, now the last part of this question morphs into a calculus question. Okay. The second part requires a little bit of tricks in algebra. Think of it like this, and I'm going to have my back to you now. See, so I can draw many cones where the ends of the base touch the perimeter of the sphere, okay? So I can make it thinner or flatter, let's say. If I take these 2 points here and bring them along the sphere up to point A, doesn't the volume of the sphere of the cone go to 0? And similarly, if I take these 2 points here and drag them down to the bottom, directly below A, and make a cone of volume 0. So the trick, the name of the game here is, there will be some point along here where the volume of the cone is maximum. And that goes back to your calculus. Okay. Right, so, what's the trick here? So I know this is x. Remember I said Pythagoras? So the length OC is x. All I have to do is draw a line from here to here. It's a right-angled cone. Aha. And look, mustn't length OB, equal r, the radius of the cone, of the sphere, which is 12. Now, it's just Pythagoras again. That's what I meant about earlier. So Pythagoras would say, no, let's take it out of the x. If you can solve these problems, I think you're good at maths, you can do these, and let's call that y. So I'm going to say length BC equals y, just so I don't like those kind of like carrying around in algebra, those kind of prism bars, BC, okay? So, x squared, by Pythagoras, x squared plus y squared must equal 144. So y squared must equal 144 minus x squared. So y equals, now here's the thing is, again, a word to the wise, caution, that's plus or minus, isn't it? The square root of 9, your calculators say it's 3, but actually the square root of 9 is plus or minus 3. Remember I said earlier, but we're dealing with lengths here, aren't we? So it must be only plus. Right? So that's what they're asking. Okay, the good news is, that's 10 out of 50. Right? Right? So, it's getting out of the starting gates on these section D questions makes all the difference. Okay? I think that's quite nice. Okay? Then it goes, and the second part, goes. Now here's where now the whole question won't be, geometry anymore, or volumes and areas. The whole question will become algebra, and then later on in the question, calculus. Going back to my earlier point. Okay? So whenever you see things like this with right angles, try and eliminate Pythagoras first before you do anything too complicated. And then they ask me to show that the volume of the cone is pi over 3. I think these are hard. And this is all from the same paper, 12 plus, which I like doing actually, because then you see, okay, they're all on the same paper, squared by 12 minus x. And let me just show you again the question they're asking here. And you can see the second part says, show that the volume of the cone. Now here we need another little trick. Sometimes visually it's difficult to see, but it does tricks. Well, if I give you a cone here, and that's the base, radius r, and it's a right angle cone, and that's the height. So the height will be from the vertex, the top of the cone, right down, piercing the middle of the circular base. Well, the volume there is pi over 3 r squared h. Okay? So here, y is the radius. So in our case, y equals pi over 3 y squared times the height. Well, what's the height of the cone? Well, isn't that length to here 12? So in our case, the height of the cone must be 12 plus x. Ah. And see, by confining the cone to sitting inside a sphere, all I've done is I've made the radius of the cone and the height of the cone the same, dependent on the same variable. Right? Because I'm confined inside the sphere. Right. So, let's finish off. I think that's a hard problem, but it's come up before. This would have come up in the 1980s, the 1990s, on the actual Levy circuit itself. All the construction questions, the games with orthocenters, circumcenters, all that kind of stuff, same questions have come up. They just might have different, might be asked in a slightly different way. So all I have to do now is it y squared equals 144 minus x squared? So that means my volume, here I can write all in terms of x. 144 minus x squared by 12 plus x. And one of our tricks in algebra, isn't the 144 minus x squared, isn't that the difference of two squares? That equals pi over 3, 12 minus x by 12 plus x by 12 plus x. Right? And just be comfortable with our algebra. Aha. Right. So now on the DEV pre-guys, that would have been another 10 marks. Okay. On the Levy circuit, that would be 15. See, because they find this difficult for you guys, because it's context and applications, if you can get out of the starting gate, they reward very highly. Then at the end of the question, to eke out the remaining marks, it can get very technical maths. Quite tricky, especially with geometry. Quite tricky. It's usually Pythagoras, but sometimes it's hard to see Pythagoras in action. But the last parts, which are more tricky, tend to only be rewarded 5 marks each. So you can get the 35, 40, in other words, veering on the lower H2, upper H3, and then the last things that tend not to attract as many marks. So they tend to be these 50-mark questions. That's why what I try to do is encourage the students to give them a go. Because they don't know the marking scheme, so they think they might have only got 5 marks so far out of 50. But no, in fact, actually, you've got it on the DB at least 20, and maybe on the DB 25. So by getting this far, because you've been able to interpret this. Now here's the interesting thing is, and this is one thing I guarantee you guys, once you can get to here, right, then we differentiate this, if we've done any calculus, to find the x that gives the maximum volume. And that's a piece of cake, again, right? So once it becomes a differentiation question, at least you know what you have to do. It doesn't mean that we don't screw it up, but at least we know what we have to do. Okay? And I know you guys got a class yesterday, you attended it for exponentials and logs. So some of the technical maths I haven't done, but at least we've touched on simultaneous equations, it's a very good one. We've done quadratics, and nothing more, I haven't talked about too much about different roots and conditions there. But graphing them is the thing that I find students just find the most difficult to get used to. Okay? And if you see the same trick applied for quadratics as applied for cubics, then we did two full questions, or two 10, if not 15-mark questions from paper 1 from the DB pre. And then we set up, I know we can't do the calculus today, and then we set up a 50-marker in section B. I think it's not bad for a morning, and I don't know if it's still pouring rain, but it's not a bad day to do that. Alrighty guys, lovely meeting you guys, and I don't know who you are. Okay? Enjoy your rest of your day. Bye.